Hello, and welcome to the Superb AI Academy. My name is Sam, and today I'll be talking about Curate, and specifically, curate what to label. When data is uploaded to Curate, we generate embeddings for the data. These embeddings, once generated, will allow us to group images by their similarity, which will let us extract useful information about your dataset, even if it's without metadata or isn't annotated. You can see our scatter view video for a way to visualize these embeddings. One of the key ways our Curate platform uses these embeddings is our auto-curate options. These allow you to automatically select subsets of your data for particular purposes, such as detecting mislabels, identifying edge cases, and selecting validation sets for model training. Today we'll be looking at our Curate What to Label option, which will select an initial subset of data for labeling. This data can be either unlabeled or pre-annotated. The algorithm will use the generated embeddings to select a maximally diverse set of data, making sure that large numbers of similar images aren't included and that rarer, valuable edge cases are included. This ensures that your first iteration of model building is as effective as possible. Let's jump right in. When using AutoCurate, we can use any slice or subset of our dataset, but in this case, let's start with images without annotations. You can see here that I've filtered by images that have 0 annotations. Once I filter my dataset, I'll select the Auto Curate button. This brings up a list of options. As we're working with unlabeled data, 2 of the options are unavailable for now. We'll talk about these in another video. For now, I'll select Curate What to Label. We're working with unlabeled data here, so the algorithm will be looking for diversity at the image level. If you have pre-annotated data, you can use this and select the Include Label Data option to ensure diversity at the object level. Now we'll select the number of images to curate. Let's pick 4,000. Finally, we'll just have to select the slice name. Let's call it Curate What to Label. And then we'll click Curate. The curation process will take a few minutes. Once it's complete, we can see our created slice in the Slices tab. Here, we can see that 4,000 images have been curated. To get a quick sense of the curation, we can look at the scatter view for this slice. I can select this checkbox to compare the scatter view with the dataset as a whole. While this is a very simplified representation, we can quickly see that our curated slice has a good distribution in the embedding space, and that denser regions, such as this one, tend to not be correspondingly over-selected from, as a random sampling might do. From the slice view, we can send this data to the Superb AI label by using this button. We can also auto-curate it or filter it further using the query builder. For more information about an auto-curation we've run, we can click on over to the Auto-Curate History tab. Here, we can download reports on all auto-curations that have been run. Let's take a look at this most recent report for our Curate What to Label. Here we can see a quick overview of the curation. 4,000 images curated from just over 20,000. Scrolling down, we can see a summary of the curation's cluster coverage, as compared with a random sampling. A cluster here is a set of images that are close in the embedding space and are expected to be visually similar. We can see that the random sampling only picked images from less than half of the clusters, whereas our curation algorithm selected from close to 80% of the clusters. Scrolling down further, this graph shows the difference more starkly by looking at the cluster coverage with respect to cluster size. Smaller clusters of 1 to 5 images are images that are visually distinct from the rest of the dataset, and as such are highly likely to be valuable edge cases that should be included in the model training pipeline. Here we can see that the random selection misses a high proportion of these valuable edge cases. Finally, we include some examples of sparse and dense clusters for review. At a glance, we can see that our dense clusters tend to be low information night images, many without objects or vehicles. Our sparse clusters, on the other hand, are varied and tend to have a high number of objects and vehicles, making them more valuable to label. Using this report can help better understand your dataset, and Curate What to Label can help you best select that crucial initial slice when starting data labeling efforts. That's all for this episode of the Superb AI Academy. I'll see you next time.